Welcome to the 2019 REBNY PropTech Challenge finalist presentations in partnership with the MIPIM Startup Competition. This year's Operations and Maintenance category was sponsored by NYSERDA, the New York State Energy Research and Development Authority.
Next up, we have Derek Cederbaum from Enertiv.
Hi, I'm Derek Cederbaum.
And I'm Eric.
And we're with Enertiv, and we help transform building operations into asset value. Now, in today's built environment, commercial real estate has a variety of fragmented and disjointed systems. You have BMSs that turn systems on and off. You have ticketing systems that generate work orders or a very expensive task list, to-do list. You have tenant sub-metering, which is highly manual and reactive, and preventative maintenance programs, which is largely done on pen and paper in a majority of assets in the marketplace. And so what Enertiv is trying to do and successfully doing is we identify the lowest cost strategies to reliably capture the data needed to deliver the value that owners and operators are looking for streamlining operations, maintenance, repairs, utilities, so on and so forth. And the way in which we accomplish that is by deploying hundreds of equipment-specific sensors, more affordable than anywhere in the marketplace today, to monitor anything from energy usage to actual runtime hours, like an odometer. We digitize physical spaces and documentation, so taking O&M manuals, spec sheets, nameplate capacity, so on and so forth. And if possible and where necessary, we'll integrate with existing systems, a BMS, a ticketing system like IBM Maximo, so that we can connect all of this disparate data and provide a single source of truth. Now, transferring all of this data to the cloud is a great first step. There's a lot of providers in the marketplace today that can provide all this data on a dashboard and can give you a variety of conditions from energy consumption to temperature, so on and so forth. And again, great first step, but it's not actionable and it's not enough. We live in an increasingly complex world, and so do real estate operators. Because of that, engineers, asset managers, they have a day-to-day job. They cannot deal with the increasing complexity. What they need is for an ability for their operations to not remain manual and reactive, but to be more proactive and more predictive. And so what's needed is a digital engineer.
My team is responsible for taking all of this disparate data, along with from operations manuals, from BMS data to our own sensors, building a library of understanding about equipment, so we can build actionable notifications and alerts and understand pre-fault conditions for these equipment, so that your operators can fix things before they go wrong.
So essentially what we're looking to do is take massive data sets connecting hundreds, thousands of boilers, chillers, elevators from across the built environment, one building, a portfolio of buildings, an entire marketplace, and we're using that data to build out these algorithms, to build insights with our data analysts, our mechanical engineers on staff, to help owners, operators, engineers, property managers, and asset managers get greater transparency and accountability into their assets. Overall, the goal is to automate and streamline maintenance, repairs, utility management. I mean, energy efficiency is really nothing more than a well-run and a well-maintained machine, knowing when, where to maintain, replace, or upgrade. Our data, our insights, and our service team provide all of that. Gotcha.
Questions from our judges?
Can you talk a bit about your analytics package, and ultimately A and B also talk to the issues of integrating directly into the BMS and how you're extracting data from the BMS?
Sure, two very good questions. So to answer partly about the analytics, what we're effectively doing is taking large data sets of this system. So for example, with chillers or pumps, you have hundreds of thousands of pumps, yet one pump in one building will not have all of the answers to different failure modes, short cycling, voltage fluctuations, so on and so forth. So what we do by having our low-cost sensors and monitoring hundreds or thousands of pumps is creating this data library where we can take learned instances of where there was short cycling, what it looks like in the data, where there is schedule drift or set point drift, what it looks like in the data, hard coding that into an algorithm, and then reapplying that to the entirety of our client portfolio, so every building can benefit from one error in one system in one building. To answer the question on the BMS, there's two answers to that. One, and I'll let you answer second, how we actually do it. We can work across asset classes and types, so multifamily, office, class A, B, and C, industrial, hospitality. So there are instances where we do extract data from the building management system. We work across asset classes, so we can deliver value, whether or not there's a BMS, or whether the BMS is digital, or in unfortunate circumstances and across the country, pneumatic, where there isn't really an ability to extract that data. But to answer the question on digital BMS.
So we've communicated with BMSs using industry standards such as BACnet, Modbus, other protocols, as well as deploying sensors when needed to get that data directly.
We'll use standard market data acquisition devices to do so.
So you're actually doing the integration into the BMS yourselves, or is that a third party that comes in and does that?
So we're a full service provider. We will at times design and deploy sensors and hardware and data acquisition devices, or we will acquire third-party devices like for BMS integration, but we will facilitate the installation, data acquisition, and data transmission into our software, where we have our analytics packages, and where our analysts and our mechanical engineers service that data as well.
And is this all in real time?
Yes, sometimes there's a slight lag in data, which is why we're not designed to control, we're designed to analyze and prescribe. But whether there's a 1 or 2 minute lag, it's all up-to-date, real-time information.
What is a typical deployment, maybe a 500,000 square foot Class A office building, and how long does it, what's the typical deployment, how long does it take? How many buildings are you in right now?
Sure, so we're in approximately 200 owner-operator buildings across the US and Canada and a little bit in Mexico. In terms of a typical deployment for a 500,000 square foot asset, we might put in 15 of our own devices, which each device can monitor up to 42 pieces of equipment at the sub-second level. So we will deploy 400 to 600 sensors to monitor those systems. Again, that's 7 variables on power data, runtime hour data, dollar value from an empirical perspective. And from an installation perspective, it's standard electrical subcontractors for the most part when it comes to sensor and device deployments, in and out of a building in 1 to 4 days, depending on conditions. No permitting requirements, no power shutdown requirements. And then there's the commissioning of data, which comes from putting in cellular gateways to get the data out, not having to deal with internal IT or cybersecurity concerns. And then it's doing data quality checks in our back end for the first few weeks.
Give it up for Enertiv.